Okay, so let's assume, without loss of generality, that J1 is either greater than or equal to J2. Okay, one of them is either greater or less, right? So the one that is greater, we just call them system 1. So physically, we expect the greatest total angular momentum when the two component systems are parallel. What does this mean? This means that both of their z value of angular momentum is pointing in the same direction. So in that case, we would expect J to be, say, J1 plus J2. So this is a conjecture, okay? We are conjecturing. This is a conjecture. We're going to verify all of this. And the minimum, total angular momentum will result when the two component systems are antiparallel. Okay? So in that case, J should be J1 minus J2. So this is also a conjecture. Now let's see if these ideas are born, they work. Okay. So we want to express everything in terms of J plus, J minus, J1Z, J2Z, etc. So let's take J squared. Yeah, do you have a question? So J1 squared is, J squared is J1 squared plus J2 squared plus 2 J1 dot J2. Now it's easy to show that this guy, 2 J1 dot J2 is J1 plus J2 minus plus J1 minus J2 plus 2 J1Z J2Z. Why are we doing this? We are doing this because we want to express our total result in terms of eigenstates of these guys. And we want to convert any Jx, y, etc. to plus and minus because we want to move up and down the ladder. Right? This guy moves you up the ladder of the first particle. This guy moves you down the ladder of the second particle and vice versa here. Okay, so using this, we can now express J squared as J1 squared plus J2 squared plus J1 plus J2 minus plus J1 minus J2 plus 2 J1Z J2Z. Okay, any questions so far?
Sir, why did we express the dot product in terms of the 1 plus and 2 minus
Yeah,
of the other?
yeah, you just have to, I'm leaving that as a homework, as an
Oh,
exercise.
okay.
Okay. It's one line of algebra. It's just very easy. But it's good to do because it will help you get a grip on a tensor product as well. Okay, I mean, it's very easy. I mean, it's just like, all you have to use is the fact that, yeah, I'll let you do it. Yeah. So now, we said that the state with the highest amount of total angular momentum, J, will be J1 plus J2. This is our conjecture. Okay, so, because J1Z, because Jz is equal to J1Z plus J2Z, such a state would be given by the tensor product of this state, J1 tensored with J2. Remember that these quantum numbers are fixed, but we can vary these numbers. But of course, if we apply Jz on this thing, we are going to get the J1 plus J2. Okay. So let's see if this is, so our conjecture is this is going to be Jj when J is this. Let's see if this is true. So let's apply to the right-hand side, so yeah. So let's apply J squared to J1 times J2. But we just figured out what J squared was. J squared has J1 squared, J2 squared. So that's going to give me J1 plus 1 plus J2 plus 1. And then I have a raising operator of J1. But see here, J1 is already in the maximally, the highest weight state, right? So if I raise it anymore, it's going to give me 0. So I'm going to get a 0 from there. And similarly, this thing has a J2 plus, and that is also going to give me a 0. And then I will have this guys, they will just give me the eigenvalues twice, multiply of the eigenvalues. So I'll get 2 times J1 times J2. So this will be the whole coefficient, and this will be multiplying J1, J2, because none of the operators were able to change any of these states. So these states will remain. Okay, so now we can simplify this thing. So we see here J1 squared, here we see here J2 squared, here we see 2J1, J2. So we can write that as J1 plus J2 whole squared, plus we see here J1 and J2. So we have J1 plus J2, and then we have J1, J2. So here we see that here we have J1 plus J2 times J1 plus J2 plus 1 times the state. But what is this? This is nothing but J, And this is nothing but j plus 1 times the state. So the first test, it passes the first test. What is the second test? The second test is the Jz eigenvalue. The Jz eigenvalue of J1, J1, J2, J2 is very easy. It's just very trivial to show that it is just J1 plus J2. Sorry. And therefore, we have shown that the state Jj, when j is J1 plus J2, is given by the tensor product of J1, J1 and J2, J2. Okay? Clear? Any questions?